Yeah, we've been looking to.
Okay, hi, Paul Slackis, Good News Planet. We're going to talk about blood.
Right.
All right, so that's
Right.
I stopped for a second because this is a serious issue, and I
Very
believe that
serious.
everybody has blood. In fact, I think animals even have some blood in them too.
Yeah, they
And
do.
so we're going to talk about blood because blood is such an important aspect of humanity. In fact, without it and without good blood or without enough blood, it's not a good story. It's not good
No,
news.
no.
So we have here Jimmy Walker. Hi, Jimmy. How are you?
I'm very well, thank you. How are you?
All right, good. Ted Robinson, yourself? How you doing?
Very well, thank you.
And my good friend Sunil. How you doing, Sunil?
Thank you. I'm very good, Paul. I appreciate your effort and taking time to take this interview.
Sunil's the producer of putting this all together. I want
Yes.
you all to know that. And he
Good
pulled it
friend.
all together because he showed me some videos and some of the work that you're doing. So maybe Jimmy, maybe you can start us off. Tell us the kind of good technology you have here. It's magnificent.
Okay, thank you. Are you familiar with the blood process and management of blood at all?
Well, let's say I'm the audience.
Okay.
I'll say no.
Right.
I know a little.
Okay. Well, blood, shelf life of blood, once it's donated, it only has a shelf life of 42 days. On day 43, you're not able to use it for blood transfusions. So we were developing a company called Sea Level Clone, which we were taking equity positions in small startups and so forth. And in one of my past lives, I had a large medical distribution company. And one of the things that we did is we sold and distributed cryosurgical products. So when we started this company, we went out on LinkedIn and started looking for different opportunities and so forth. And this gentleman reached out to me and asked me if we saw I had experience with cryosurgical products, asked if I ever heard of this process where they were freezing and thawing blood that was stored. And long story short, we didn't. And he came back and we started talking, and he said this technology was originally developed in the 60s under a Navy contract, where they were looking at ways to increase shelf life of blood because of being on bases, on board ships, and so forth and so on, where it has a limitation of 42 days. So they developed the process. It took them about 10 years and about $20 million. And they developed a process where they were using a method, a liquid nitrogen and what they call a heat transfer rate, which is the rate which they freeze the blood and the rate which they thaw the blood. And by doing that and being successful with it, they were able to basically eliminate the shelf life of blood, because once it's frozen and goes down to minus 196, all life stops. So the problem they had back then was that they were developing it in glass bottles and in cans and so forth. So the next phase of it was to develop a plastic bag. Back then, the technology wasn't there that could withstand minus 196. So when it came back to that, came to the second phase, the contract was terminated and never went to the second phase. But Union Carbide was allowed to go to rural parts of the world to basically introduce the process for basically rare blood. It's all, just rare blood that they could use that process to eliminate the shelf life of rare blood. And then it just fizzled off and died. So we started looking at the market for that and realized that, there's 97 billion bags of blood drawn annually. Only 2% of the population donates blood. And, there are parts of the world that there's 70% of the blood is contaminated. So we did, for years, we've been going through this and doing a lot of research on it, both from the marketing side and from the research side. And what we discovered is that with our process, we can eliminate the shelf life of blood indefinitely, which also includes bone marrow. We have to add a cryoprotectant to that, which is off-the-shelf cryoprotectant that gets added, which helps with the recovery rate of the cells and protecting the cells going down to that level of temperature. And then after that, you have to prior to using, you have to do what they call washing of the blood. So what we discovered, first of all, was that the biggest demand for blood right now is platelets. Platelets only has a shelf life of 5 days. And out of that 5 days, it takes really 2 days to prep for it. So it's really only a 3-day window. So one of the problems that we had was nobody could really tell us what the market size of platelets being thrown away. American Red Cross, the World Health Organization, AABB, they said, no, we're not really tracking that. So continue to do some research. We found that actually the United States has a blood utilization report that they publish every 5 years. And when we went to that report, we actually were able to discover what the size of loss for platelets are on an annual basis. And when we went through that, we discovered that the market size for platelets is about $3 to $5 billion a year. It's huge. Now, one of the other things that we discovered is that with platelets, you don't have to isolate platelets, which is traditionally what you do right now. You lie on a table for 2 hours with needles in both arms. One side, it extracts the blood, puts it through a machine, extracts the platelets, and then we put on the other side, puts the rest of the blood components back in your body. With our process, all you do is draw blood, add the existing cryoprotectant that's already FDA approved right now to the blood, and the platelets would be available forever. So that one process alone is a $5 billion marketplace. And we're in the process of introducing our technology for that particular phase as we speak. Now, the next phase of our technology is that we will, and we've done research on this preliminarily, but we're going to do further research on it. But we'll be able to eliminate most, if not all, contaminants in blood. Ebola, E. coli, Hep, A2C, et cetera, et cetera. What we're going to do as part of our launch is to introduce or do the further research on all the different components that we can eliminate, the viruses that we can eliminate, and bacteria that we can eliminate and identify. Because one of the processes in cost incurment, in cost expenses for blood management is identifying what contaminants and bacteria are in the blood. So we show that we can eliminate A, B, C, D with our process that eliminate that whole process as far as blood management is concerned within hospitals and blood centers. The other phase that we're going to be introducing, which is kind of like 3 and 4, is we're introducing a new cryoprotectant. As I explained earlier, the cryoprotectant that they use now has to be removed prior to being used in transfusions. With the new cryoprotectant, which is already FDA approved for consumable products, food, eye drops, makeup, et cetera, it's such a low dosage that you will not have to be removed prior to being used for transfusion. So all you do is bring it up to room temperature, and you don't have to remove the cryoprotectant, and you do the transfusion. So by that, you're introducing a new cryoprotectant, and you're eliminating the need to have that wash prior to use. Okay, so that's tremendous. And the other side of this is that in all cases, not in all cases, let me rephrase it. In most cases, to introduce our IP to a hospital or to a blood center, there's no capital investment. Most hospitals and blood centers have the freezers that they need to bring this down to minus 196. So all they do is they just license our IP, and they have the technology, and they've eliminated that particular cost of shortages that they incur every year. And the cost, when you go through and do a market research, the cost that these hospitals incur because of shelf life is staggering, absolutely staggering, because of shelf life, because of contaminants, because of poor management per se. So on a $30 million budget, which is pretty small in a lot of hospitals, but it's about average, they lose a third of that. That's $9 million a year. So you're going to save them $9 million a year without having to spend any capital investment by just licensing our IP.
So
Okay.
You'll put this. We'll put some text along with this interview You have a couple links I saw, and I watched some videos that also explain what we're talking about here.
Mhm.
So make sure you have those YouTube links in here. Is it Dr. Ted Robinson? Is that right?
Yes.
How are you involved?
Well, Jimmy has invited me to come on the board of the company because of my background. My background is I am by profession a plastic and reconstructive surgeon. And in addition to my professional qualifications, I've been in the capital markets for many decades, put it that way. And so it's rather a unique combination of knowledge, experience, and skills. And he feels that I can make a valid contribution to the company.
Let me ask you a question. I don't know much about cosmetic work and surgery and things like that. I guess I mean blood is everywhere, right, in our body. So is there, for example, is there blood in the face?
There is blood everywhere. Every cell in your body requires oxygenation, and it's carried there by the red blood cells in our blood.
So if you were gonna, fix up this double chin, or you were gonna get me looking like I was 12 again, you would need to know something about blood because that's your work. Yes.
You need to know something about blood. You need to know something about areas of the body that have poor blood supply, and you need to know about conditions where there is a severe lack of blood because of burns or motor vehicle accidents, other forms of trauma, bleeding after pregnancy, anemia, cancer. These are all situations in which blood transfusion is required, and in some cases, a significant amount, which can be not available, depending on the situation, the amount required, the number of people that have been injured or burned. I used to be in charge of a major burns unit in London, England. We serviced all of the UK plus Europe plus the Middle East. I, in one situation, was phoned from Libya that there had been an explosion on an oil pipeline, and they were sending me 80 patients. Probably most of those were severely burned and would require a significant amount of transfusion. There is a chronic shortage of blood. This process will probably more than double the world blood supply.
That's magnificent. I'll just share one quick story, a 9/11 story. When we were watching the 9/11 scenario occur on that morning, my daughter and I, my wife at the time, she was at work, and she said, "Put the television on, the World Trade Center's problem." We watched it because she was in Queens, and you can get a good view of the city here. And we heard some doctor say, "We're going to need blood." And my daughter and I were the first people in the Red Cross down here on 76 in Amsterdam or whatever to donate blood. That comment, unfortunately, unfortunately, they didn't need blood because it didn't, people just died. And so blood is a very serious issue. If you have all this good technology. So Neil, I can see why you got involved with this. How did you all get together?
Yeah, because I love saving and extending human life. And as I told you earlier, that I am only one in the world who saved thousands of children's lives by facilitating global medical conference that helped to control virus that was way more dangerous than corona within 18 days. And that excites me a lot in terms of technology, in terms of people, whoever are doing this great kind of work to contribute toward world peace and towards humanity. And that is how I get involved with all the leaders in the world. And fortunately, I am lucky that all the leaders from every single background, every single country knows me because I give lots of media conferences in India and use media extremely well.
Great, great. Ted, did you want to say something after I said something? I didn't, I meant, I apologize.
Yes, I did, because Jimmy talked about contaminated blood. And contaminated blood is an enormous problem. You know, in the early days of the AIDS epidemic, a lot of people were dying because of contaminated blood transfusion. That problem has now been rectified in the first world, but not so much in the second and third world. If you go to places like Africa, where there is a significant chronic shortage of blood for transfusion, a lot of the blood is contaminated. And, you know, Jimmy referred to the biological contaminants, but you know, there's a long list. It's viruses, it's bacteria, it's parasites, and you know, diseases like malaria. And if you're in an emergency situation and you have blood, you grab it. But in the process, you may be giving that patient another problem. And to the extent that the freezing or cryoprotectant process can eliminate these, you will have a much cleaner, safer blood supply.
So Jimmy, and thank you, Ted, and thank you, Sunil, of course. You know, how can the world help you move your discoveries, your research? How can we help you move it forwards? What's the good news? How can we move it forwards?
Just, we need to get awareness and get some funding to launch the technology. As far as the launching it, it's a no-brainer, Paul, because when you go with our process to donate blood, you just go and donate blood, add the cryoprotectant to it, and it's all components of that blood bag, in that blood bag, are available forever. So traditionally what they do is you draw blood. If you want to draw leukocytes, you have to go to a machine, draw out the leukocytes for 2 hours. Same thing with plasma. Same thing with you know, platelets. Our process, you just donate blood, add the cryoprotectant to it, put it in the freezer through our heat transfer rate, and it's there forever. So when you look at that and look at the recurring costs for hospitals on that, all you do is have a station set up to just take blood 20 minutes later, and you have all the blood components. Getting volunteers or donors to draw platelets is a very monumental task, because nobody wants to lie on the table for 2 hours with needles in both arms. It's difficult. But with that process, you just draw blood, add the existing cryoprotectant, and then you have blood forever. And so, and when you look at that and look at the cost savings, not only the recurring cost savings, plus the cost savings on what it costs for them to lose blood, it's monumental. And they're not spending millions and millions of dollars to get this equipment in here and special equipment and so forth. It's just licensing our technology.
Let me ask, sorry, no, go on.
Go ahead. No, go ahead.
Let me ask just one last question at this moment. I'd love to speak again, and I wish you great major success. Is there water in blood?
Plasma.
No. There is not. It's what we call serum.
Yeah.
Serum is what remains after you have removed all of the red cells, the white cells, and the platelets. And it is a watery substance. In situations where no blood is available, you can transfuse just serum to at least elevate the level of proteins and provide volume to a patient that's in shock. But what I wanted to talk about, and this also excites me because the future of this technology is not limited to red blood cells or platelets. You can transfuse, stored white cells, which are important for the immune system. You can store stem cells, which are important for rebuilding the tissues. We think that in the long run, that this could be used for bone marrow and possibly for organ transplantation.
Serious, congratulations. So serious stuff.
Thank you.
Well, all right. Well, where do people go? How can someone reach out to you? And is there a website? Is there a phone?
Right.
What's the best way?
The website right now that we have is the letter C hyphen LEVEL, so level clone, CLONE.com. So it's C hyphen levelclone.com. Eventually we'll be changing it to cryomedics because we're isolating the blood business out of C-level clone because we had other products in there, but we're going to isolate that and put into Cryomedic Technologies as a standalone. And but right now, C-level clone will get them, C-level clone will get them to our website.
Okay.
Okay.
All right, gentlemen. Thank you very much for taking some time to discuss this marvelous discovery.
you so much.
And now let's get it to the world. These are staggering commentary here that you're saying 2%. You know, you give blood and the need for blood and blah blah blah. It's this is another one of those things where we should all be part of the solution. So thank
Exactly.
you very much. I appreciate it, the time.
Thanks for your
Thank
time.
you.
Appreciate it.
Thank you.
I'll send you
Thank
those
you,
additional
Paul.
information. as
Thank you,
well.
Paul.
Okay, guys. Thank you.
Thanks, Paul.
Thank you. Bye-bye.
Bye-bye.
Bye bye.